We're going to look at this program called Tideman, in which we are supposed to figure out the winner of an election based on a ranking system. Okay, so first of all, you should download this file using this wget command on the terminal. After that, I'm gonna fill in these to-dos over here. Meanwhile, smash that like button. So what we have to do here in the vote function is, given a name, we must update the ranks array. Okay, this ranks array must be updated by the index corresponding to the name. Okay, what I'm going to do here is I'm going to figure out the index of that candidate. I'm going to create a function of my own called getIndex. Function getIndex string name. I'm going to iterate over the candidates array. I equals 0, I less than candidate count. This is a global variable, I++, and then I'm going to see if strcomp. I'm going to compare the ith candidate's name. So candidates array is just the string array, and I'm going to compare the ith candidate's name and the name given to me in the parameter, and I'm going to return I for that. And finally, I'm going to return -1. If I cannot find the name that's been given to me in this candidates array, I'm going to return -1. Okay, so I've written this getIndex function, find the candidate index. After doing that, I'm going to say if candidate underscore index, if this is not equal to -1, it's equal to -1, then I know that I haven't found such a candidate index corresponding to the name. Now I can continue if the candidate index is a valid index. Okay, so the index must be greater than 0, and if it's greater than 0, I can continue. So if it's greater than 0, if there is a candidate corresponding to the name that has been given to me in the parameter, then what I need to do here is I am going to say ranks of rank equals candidate underscore index. Okay, and I'm going to return true. At a given rank, I'm going to set that given rank to the candidate index. The next function over here is record preferences. So in record preferences, we need to update the preferences given one voter's rank. We are supposed to iterate. So what we can do here is we can iterate over candidate array. So, and what I'm going to do here is I'm going to say j is to I+1, j less than candidate underscore count, j++ preferences of ranks. So what happens is this time I need to update the preferences array. Okay, in the previous function, the vote function, we had to update the ranks array. This time we need to update the preferences array. Okay, so I'm going to say ranks of I and ranks of j ++. So what this means is that whatever I ranks of I is, I'm going to move and I'm going to look at all the other ranks that are ahead of this particular rank, and then I'm going to update the preferences array accordingly. What I'm saying is if there's a this is the array in ranks 0, 1, 4 and 5, 4 and 3, for example, 4, 3 and let's say 2. Okay, then if ranks of I is 0, then ranks of I+1 all the way till the end of this array, all these people are not preferred over this guy. Okay, so what we need to do is we are updating in my preferences array, I'm updating the number of people who are sort of below me. So I'm saying at ranks of I, ranks of j, every single person at ranks of j is below me, so I'm going to update that count. Okay, so this preferences array stores how many people are sort of below my preference. Okay, this is the array, the number of voters who prefer I over j. It's the number of voters who prefer I over j, right? So after doing this particular function is over, and we need to look at the next function, which is add pairs. So in add pairs, what we are going to do is we're given this struct pair on top, and every single pair consists of two fields, a winner and a loser. And we are supposed to add all such pairs, okay? All such pairs of winners and losers. So to do that, I'm going to go here. I'm going to say for int I equals 0, I less than candidate count, because I'm iterating over the candidates, all the candidates. J equals 0, j less than candidate underscore count, j plus plus. And if I find if preferences of ij is greater than preferences of ji, then what this means is we found a winner. Okay, what we're doing here is we are looking at the ith candidate. How many number of people, how many number of voters is the ith candidate? We're looking at how many number of voters are there who prefer the ith candidate over the jth candidate, and we're comparing that with the number of voters who prefer the jth candidate over the ith candidate. And after having done that, having found a winner, what I'm going to do is I'm going to create a pair p, and I'm going to say pair p dot winner equals I, because I has more number of people supporting that person, and p dot loser is going to be j. Okay, and then what's going to happen here is I'm going to say pairs of pair underscore count plus plus, because pair count is the global variable, and we need to maintain how many pairs we have in this array of ours. So pairs of pair count plus plus equals p. We've added this pair p to my global array called pairs. We have a global array of pairs over here. Okay, so now this function is done. After doing this, what we need to do here is we need to sort this pair, and there are many ways of sorting. You can implement the sorting algorithms yourself, or you can take the help of an algorithm present in the C library inside, I would say, standard lib.h hash include std lib.h. Come back here, and I'm going to use this qsort function, which is short for quicksort. So what quicksort takes, it takes an array, and the size, the number of elements in that array, which is stored in pair count. Okay, as you can see here, we are incrementing pair count. This is a global variable, this is also a global variable. After doing that, it needs the size of every single pair, and then we need a function to compare these pairs with. So we're going to write a compare function. Okay, so what this compare function needs to be, compare function, if you look at the documentation, needs to be in a very particular manner. It needs to be of const void star element 1. Let's call this element 1, and the next element is going to be called element 2. So we are comparing two elements, so we need these two parameters. If you want more details, you can look at the documentation of qsort. Then what we want to do is we want to typecast element 1 into pair, a pair class, not a pair class. We want to typecast element 1 into a pair variable, and we need to typecast element 2 is this is a pointer, right? So we want to go inside this pointer, but before doing that, we must typecast this again into a pair. I'm going to typecast this void star into a pair star, and then we want to dereference that to get a pair over here. Okay, now we can compare these two pairs, and we can say, you know what, I'm going to return preferences to the global variable in which we store how many voters prefer the ith voter over the jth voter, right? So in this case, what we need to do is we want to find the winner, the first pair's winner, how many people supporting this guy over the other guy. So over the winner, how many people are supporting the winner over the loser. Okay, so we're going to figure out this, and we're going to subtract that by this function. This is the first one. Okay, so how many people support the winner of the loser? I'm going to find the margin. Okay, we're going to find the margin of victory. So to do that, I'm going to say, I'm going to just interchange these two indices. So I've got s.loser and s.winner over here, and then this has to be compared with the next element. Okay, so I can say, you know what, I'm going to say this is the first margin or the second margin. Okay, something like the second margin. The first margin is going to be something similar. First margin is going to be the first guy. So we figured out the margin of victory, and then we need to sort this in descending order. So I'm going to return second margin minus first margin. Okay, you can look at the documentation for more details on why I need to subtract the second thing from the first thing. This is how we do it to get sorted order in sorted descending order. Doing this, we're going to look at log pairs function. So log pairs is a function extremely tricky. What we need to do is we need to log pairs into a candidate graph. We need to think of this problem as a graph problem, and every single time what should happen is we must look at the order of every single pair. Okay, we sorted these pairs and look at the largest margin of victory, and we take that, we create an edge, and we keep on adding edges until there is a cycle. And if there is a cycle, we are going to ignore that cycle and move on to the next one, to the next pair. Okay, I'm going to say for, I'm going to iterate over all the pairs. I'm going to say int I equals 0, I less than pair underscore count, I plus plus, and we'll look at locked. So locked is my graph over here. So I'm going to look, graph is a boolean which says I, it says that locked ij. What it means is that the ith candidate is locked over the jth candidate, which means that the ith candidate is winning over the jth candidate. Okay, so we keep on adding these edges one at a time, looking at the pair with the highest margin of victory. Say locked of pairs of I dot winner and pairs of I dot loser. I'll set this to true. This means that I have locked pairs. After that, I'm going to look for a cycle. So I'm going to create a function called hasCycle, okay, which says, you know what, I'm going to check if it has a cycle starting with vertex I. So I'm going to check for cycle in this directed graph starting this graph over here. So this is the candidate graph locked, and it's a directed graph because there are, you know, arrows from one candidate to the other candidate. Okay, so we can check for cycles in this directed graph and check starting with the ith candidate. So what is happening here is I've started with Alice. I've added the graph, the edge to this graph, and then I'm going to check from Alice if I have sort of a complete circle. Okay, I'm going to define this function over here called has cycle, and then I'm going to have a starting index. Okay, so I have been given a starting index, an index corresponding to the candidate, and I'm starting with that index. I'm going to check if there's a circle or a cycle in this graph. So if there is a cycle in this graph, I'm going to undo my changes. So this entire thing, I'm going to undo that, and I'm going to remove this edge. Okay, so if you look over here, I'm going to add this thing, and if there is a cycle, I'm just going to undo it. So I'm going to remove this and I'm going to go back. Okay, I'm undoing this part. Go here, verify. I'm going to set this back to false. Okay, after doing this, what I'm going to do is I need to, you know, create and define this function has cycle. So how do we check if a directed graph has a cycle or not? So in this case, there is a cycle. You can see this guy, there is a cycle. So how do we do that? We're starting from my starting index. What I need to do is I need to, you know, maintain a Boolean array. I'm going to maintain a Boolean array here called visited. Okay, this is my logic. What I'm going to do is I'm going to maintain a visited array, and I'm going to look at all the candidates over here. I'm going to figure out whether I've visited this particular index. Okay, starting with this index. Then I'm going to start from here, Alice, then I'm going to move on to Bob, and move on to Charlie. And if I move back to Alice, and if I've already visited this index, then I know that there must be a cycle in this graph. Okay, so I'm going to do that. I'm going to create a visited array, and the number of elements in this visited array is going to be equal to the number of candidates. Then I'm going to iterate over all my candidates, all the candidates that I have, and I'm going to set the visited. I'm going to set visitor divide to false, which means that I have not visited, initially I have not visited any of these candidates. And then I'm going to use another function called, you know, return has cycle helper to determine whether I have a cycle or not in this directed graph. So I'm going to do this. I'm going to pass in the starting index and the visited thing, just to differentiate between this guy and has cycle helper. The only difference over here is that I have this visited array with me as well. Bool visited is an array. Alright, so what I'm going to do here is I am going to say, given index, let's call this index. Okay, given an index, I'm going to say if I have already visited that index, then I'm going to return true, which means that yes, there is a cycle. There is a cycle in this graph. Okay, because you've returned to that same index. Okay, once more. Okay, otherwise what I'm going to do is, if I have arrived at this thing, at the index, then I'm going to say visited of that index equals true, because I have visited this index. And then what I'm going to do is I'm going to iterate over all its neighbors. I'm going to find all its neighbors. So to find all its neighbors, I'm going to look into the locked array. Okay, the locked array or the locked matrix is the graph that I have over here. See this, and I'm going to say if it's true that the index that I am currently at. I'm going to iterate and figure out all the neighbors of this graph. So I'm going to say if this guy is actually true, which means there is an edge starting from this guy to the other guy. Okay, if there wouldn't have been an edge, this wouldn't have been true. So if there is an edge starting from this index to any other index in this candidate array, if there is an edge from this index to any other index, what I'm going to do is I am going to call have cycle helper. Okay, I'm going to call have cycle on this guy, on the thing that is connected to me. Okay, so I'm going to say a cycle helper I comma visited, and I'm going to figure out if it is true that there is a cycle starting from this guy, then I know that the entire thing has a cycle, the entire graph has a cycle. So just to be clear, what I'm doing is I'm starting with Alice, and if there is an edge between Alice and Bob, I'm going to call Bob. I'm going to call Bob and check if there is a cycle starting with Bob. If there is a cycle starting with Bob, then there must be a cycle starting with Alice, and there must be a cycle in the entire graph. I have cycle helper. If this is true, then I'm going to return true. Otherwise, what I'm going to do is I'm going to look at the other guys which Alice is connected to. I'm going to say have cycle helper. Call that, and if have cycle helper returns true, then I am going to say this is true. I can even ignore these statements over here, right? Because you can read this as if it has been, if this is locked, if over index, if at index the ith candidate is locked, I mean there's an edge from index to the ith candidate, then you must figure out whether there is a cycle starting from the neighboring index. Okay, and if there is a cycle, then return true. You can even shorten this code even further and just say this and this. If it is true that I is the neighbor of index, and starting with I there is a cycle, you can simply return true. This finishes has cycle helper. Alright, after doing this, if we haven't figured out a cycle and we have looked at every single candidate that is a neighbor of this particular candidate that has been provided to me by the index parameter, then after having searched every single candidate and having not found a cycle for starting with every single candidate I is neighbor of this particular index, after having searched through all of them, if I don't find any cycle, then I'm going to return false. Okay, it's a little complicated. If you try a couple of examples, you can figure this out. So now the next function is, the last function is locked pairs. It's print winner. And print winner, what's going to happen is I'm going to find the source of this graph, which means that there is, let's say if this is the graph, I'm going to find the index or the node which has no incoming edges. As you can see over here, there is an incoming edge. So I have to find something like this. If I have a graph like this, to find the first edge which has no incoming edge, the first vertex which has no incoming edge, the first index which has no incoming edge, and I am going to return that. So in this case, Alice and Charlie. Alice has an incoming edge over here, but Charlie has no incoming edge. So Charlie should be the source. I'm going to figure out that source, and to do that, I'm going to define a function called getSource. And getSource, what it does is it figures out whether there was a candidate which has no incoming edges. Okay, so for int I equals 0, I less than candidate underscore count I plus plus, if I is a source, find another function called isSource. What will this do? Given an index, I'm going to find whether there is an incoming edge to this vertex or not. Vertex out of this index. Okay, I'm going to return I. If this is a source, then I'm going to return I. Otherwise, after having searched every single candidate and having not found anyone who can be the source, which means there were no vertices with incoming edges. There were no vertices that had 0 incoming edges. I can now return -1. Okay. So now the job is to make this function isSource, and this isSource function is going to return a boolean, and I'm going to say isSource int index, and I'm just checking if inside my locked array, locked matrix, if I have any incoming edge. Okay, candidate underscore count I plus plus, check is from locked index. I'm gonna check if locked ij says I is locked over j. Okay, so if let's say Charlie has an edge which enters Alice, then locked I index, this must actually be true. And if it is true, or if this is true, or simply if I locks this index, then I'm returning false. Otherwise, I'm going to return true. Okay. And now what I can do is I can print the winner over here. To do that, I'm going to say int index equals get underscore source. If index is not -1, then I can print the winner. Otherwise, I'm not going to print the winner. Okay, because there's no winner. Printf sent s \n candidates index. All right. So now I'm gonna make this, make Tideman. Oh, pairs declared here. Pairs over here. Your comp needs hash include. String.h. After that, 77. $25. Okay. Now you should run these examples over here and check for yourself. I'm just gonna run check 50. Meanwhile, try to re-explain what's going on here and summarize the entire problem. So what we're supposed to do here was the first thing that we needed to do is we needed to vote. Okay, this would update, given a new vote, it would update this ranks array and would figure out whether the given index, whether the given name has the corresponding index, and we were supposed to update this ranks variable. As you can see, we've got all correct. So now I'm going to just summarize this once more. In this vote function, what we did was we had to update this ranks array. And at a given rank, we were supposed to initialize or assign candidate index to this ranks array. In record preferences, what we're doing here is we are looking at all candidates and we're saying how many candidates are preferred over this current candidate, and every candidate, and I'm starting all the candidates from I equals 0 all the way till I exhaust the candidate count, and then I'm looking at j starting from 1 more than I, and I'm seeing how many of these people are greater than myself. Okay, and then add pairs, I'm looking at preferences array and I'm seeing how many pairs are there in which there's a winner and a loser. Okay, so I'm saying this ith preference, number of voters that I have over j, that's greater than the number of voters that j has over I. Then I'm going to add that pair in to my pairs global array. After that, I'm going to sort my pairs using this function, which is defined inside standard library.h, stdlib.h. Using this function, I'm just looking at the first margin, the second margin, and I am returning second margin minus the first margin so that I get back a sorted array, sorted by margins and in a descending order. Bool has cycle helper. Now this, we have to lock pairs. To lock pairs, what we need to do is we need to iterate over all the pairs, okay, which has been sorted in descending order. We need to iterate over all those pairs, and what I'm doing is I am adding an edge from the winner to the loser, and then I am looking for a cycle. If there is a cycle, I'm undoing that and I'm setting it back to false. Okay, so half cycle, what it does, it creates a boolean variable called visited, assigns every single candidate's index to false, and then I'm running half cycle helper with the starting index and the visited array, and I am figuring out whether there is a cycle. Figure out if there is a cycle, what I'm doing is I am adding a cycle one after the other. So I'm adding this one, I'm starting with this, I'm adding this one, then I'm adding this one, and every single time I'm adding an edge, I'm checking for a cycle. To do that, I'm starting with the ith, just the pair from which I want to add an edge. I'm checking if there is a cycle that is possible, starting with that index. And then to find whether there is a cycle starting with this index, if I have visited this particular index before, then I'm returning true, which means I have a cycle. Okay, I'm returning true after that. Otherwise, if I am not returning true, if this has not been visited, then I'm marking this as visited. Okay, and I'm looking at every single neighbor of this vertex, and I'm seeing if this is saying if I have a neighbor, if the ith candidate is a neighbor, and then I'm checking if there is a cycle starting with that neighbor. The entire thing has a cycle. Okay, the entire graph has a cycle starting with this index. Otherwise, after having looked at every single neighbor, if I don't find a cycle from any neighbor starting with any neighbor, if I don't find a cycle, then I am going to return false. Next up, we've got print winner. To find the winner, what I'm doing is I'm finding the source. So I'm searching over all my candidates. I'm checking if there is a candidate which has no incoming edge. Okay, I start with Alice, for example, then I move on to Bob. If I start with Alice and I figure out, yes, there is an edge that is coming into this, so I'm returning false. So this cannot be the source. Alice cannot be the source. Then I'm checking for Bob. I'm checking if there is an incoming edge, and yes, there is an incoming edge. Then I'm looking for Charlie. I find that Charlie has no incoming edge, so I'm returning true for Charlie. And so we have a source called Charlie, which is going to be 0, 1, 2 in this case. Okay, assuming that the indices are 0, 1, 2, 0 for Alice, 1 for Bob, and 2 for Charlie. If the index is not -1 that I get back from get source, I'm going to print that candidate. Okay, this was a long pset, not a long problem. Like, share, and subscribe. Peace.